I would like to welcome you all in the discussion of mini project. In this session, I am going to discuss a complete project idea of the topic development of bicycle-based hybrid charger with solar, wind, and regenerative braking. Regenerative braking is nothing but whenever we are applying the power, there will be like a power loss. That power loss you are going to convert it back to the supply. That is actually called regenerative braking, which is usually adopted in the electric vehicle. So that's a concept. So, solar, wind, that is a renewable energy sources. So using that, you are going to have an effective and efficient bicycle-based hybrid charger system. So we have two inputs, correct? Also, apart from that, you are going to add regenerative braking also. So we are expected to make the model which is shown on the diagram at the top end. So somebody asked you that what is your project? It is basically a bicycle that charges phones from the clean energy by combining solar, wind while riding and regenerative braking managed by very smart controller. You can use ESP32 as a heart of the device, that is microcontrolled unit. So this is what exactly the concept of the project. So we use two renewable energy sources with the regenerative braking. Using that, you are going to charge the phone which is already available in your bicycle. Okay. So here, what exactly you will build? So number one, a small solar panel mounted on the carrier or backup flap wherever you can conveniently place. Similarly, a mini wind turbine or DC generator mounted near to the handlebar or front side depends on the convenient place. A regenerative generator on the rear wheel that harvests energy during the braking. During the braking time, there will be power loss. That means that power loss will be taken as an input. A battery pack with the protection that stores energy. That is another thing. You can use any convenient battery source. A USB-A or USB-C port to charge the phone or headlight. A tiny ESP32, that is a nodal MCU that shows a live data. And you are going to add Bluetooth as well as Wi-Fi module and prioritize the sources. Okay, so ESP will decide like from where you are going to take the power. That's what exactly the controller unit does. Here, the skeleton of the project is given for you. Basically, the entire flow of this project is in this fashion. We have the sources like solar, wind, and regenerative braking or regenerative generator. Then there is a power conditioning unit. They can use like a buck boost converter with the MPPT and a rectifier unit. Rectifier for like a wind and MPPT for solar. So rectifier that will like a variable DC will be converted to fixed DC, correct? The AC, variable AC is going to convert into fixed DC. AC to DC, that is rectifier. We have the power conditioning device also. Then battery with the battery management system. That ESP32 will take care of that. 5-volt USB output then given to the phone. So that phone will be comfortably charges. Parallelly, we have the sensors then connected to the ESP32 and that will, you are going to burn the logical programming by using compiler C. Embedded C you are going to use and you are supposed to do the programming. Then there is a like a organic LED and application then connected to the user. That is a controlling part in parallel. Use the diagram to explain like a solar gets MPPT, wind gets rectified, all sources are or combined and charge the battery. ESP32 will act as a control device or it will give the priority and shows the particular data. So that is a smart controller unit. This is a basically the entire process flow which is involved in this project. So electrical design involves like a solar path, like a panel, MPPT boost, MPPT and buck boost converter, battery. Then wind path includes AC from the generator. Then there is AC to DC converter or bridge rectifier, buck boost converter, battery. Then regenerative path. There is the rear motor during the braking. It will act as like a motor mode and a generator mode. Correct, no? So here during the braking time it will act as a like it will activate during the braking time, then it will the AC power will be converted to DC power using the rectifier, then we are using the buck converter or boost converter, then battery. Then source is going to compare like there is a short key diode which will prevent the reverse power flow. Then uh, output is given to the battery. That means like a 5-volt buck converter. Then it can be connected to either USB-C or USB-B converter. The purpose of buck converter, it will maintain the constant voltage. I mean, high voltage to like low voltage. Okay. we require like we want a 5 volt. If it is more than 5 volt, the USB-C or A port will be spoiled. To overcome that, we are using buck converter. So we use the protective devices like a fuse, 5 to 10 ampere fuse. You have to purchase and install. Then TVS diode for the reverse power flow. Okay, these are the precautionary actions we are going to take care. Similarly, controller and sensing, we use ESP32 and the battery voltage, current from the each sources and the bike speed, everything will be reads. These are the inputs. Then give the priority like solar, depends on the condition, availability of solar, wind, and even regenerative braking condition. Okay. Similarly, it shows the suitable display and shows on organic LED and sent via BLE. Okay. Similarly, solar, wind, regenerative power, battery percentage on the health on USB and output current, CO2 and say like a CO2 saved estimation also will be done. So all together, you can see solar panel, mini DC motor, BLDC hub, then charge control unit, DC-DC converter, ideal diode, then ESP32, current voltage sensor, fuse, all together it will take up to 10,000. You can manage the project within 10,000. You can check out this bill of material. It is approximate cost. It may vary from the market condition. Basically, the simple operation will be in the three lines. In the daylight, keep the solar path on. If the speed greater than 8 to 10 kilometer per hour, enable wind. If brake applied, enable the regenerative braking system. Optionally, limit the USB output to protect the battery. So these are the three simple logic which is comes under this programming. Basically, the pseudocode is given here. So reading solar voltage, solar current, wind voltage, wind current, and battery voltage, battery current, and the speed and the brake. These are the inputs you have to remember. So power of the solar can be calculated by panel voltage and panel current. So similarly, wind voltage and wind current is going to multiply, and you are getting the wind power. So enable the solar during the daylight, enable the wind if the wind speed is greater than or is equal to 10 kilometer per hour, enable the regenerative braking if the brake is applied. Show OLED, power on the solar, power on the wind, all the display will be available. It will be very comfortable. In the vehicle itself, we'll come to know. This is the simple code. Mechanical mounting, solar, light frame on the rear carrier or backup flap with the Velcro. Wind, mini like a mini propeller on the handlebar stem on the front or rack for the movement. It will be comfortably you have to install. Quick release 3D printed clamp. Regenerative braking, small DC motor pressed at the rim with the spring arm wired to brake lever micro switch. Root wires with a spiral wrap keep the clear and spoke chain. These are the brief information about the mechanical mounting. So first of all, you have to perform the mounting. Later, do the proper wiring accordingly. Add protective devices. Install the sensors. Yeah, like connect the sensors should be connected to ESP32. It will act as a control device. Then follow the flash code. Then go for the testing and perform the demonstration. These are the step by step. We can go through it once again. It is very simple. Everything I have given in the step by step. So to ensure that it will prevent the overcurrent, your battery should be protected. Fuse should be installed near to the battery. Don't short solar or wind leads. It may leads short circuit. Keep wiring away from the wheel. Regenerative braking adds track during the braking only. Wind module is small. Expect the modest watts for the demo purpose. Perform the testing. Open circuit voltage under solar 80 to 22 volt. You have to conduct the test. Wind varies with respect to the speed. You can perform the charge test also. You can do it. Similarly, USB load test can be done. Similarly, data verify, just check the display whether the display is proper or not. These are the basic tests you can do it. So proper result, expected results are peak solar power at noon, wind power versus speed of the table. How much amount of solar power is generated, wind power is generated. You can calculate the current during the braking. Total energy you can calculate for 30 minutes. Then CO2 saved you can estimate. Okay. So these are the important results you will be getting, and you can plot it as a waveforms. So working triple hybrid bicycle with the USB charging will be delivered, and the ESP32 dashboard with the entire display also will be available. Wiring diagram and code and bill of material. 2 minutes demo video also should be prepared. Then like a short report with the data table and graph for the final submission to your department. So basically, our bicycle charges phones using the solar wind while riding and regenerative braking. A smart ESP32 prioritize the sources and logic power. Energy is stored in the battery with protection with the delivered via 5-volt USB. We verified the gain from the each sources and showed live data on OLED and applications. It's low cost and portable and green. So suitable wiring diagram should be prepared and the starter ESP32 code also should be required. These are the major things and also suitable mechanical setup. So if you have any queries, you can contact us. We are going to support you for the completion of the project. I wish you all the very best for your project. Do well and parallelly plan for a better paper preparation and get the good result. If you are watching our channel first time, request you to subscribe. Also, kindly share the video those who are working on the mini project, especially the domain of electrical and electronics. Happy learning. I wish you all the very best for your project and do well and take everything in